Hi, I'm Bob from Hauptwerk Hardware, and in this video we're going to talk about these lighted pistons. As it turns out, there's quite a lot to say about these, and there are a lot of boards, interface boards for the System 1 lighted pistons. In fact, there are 6 different boards devoted solely to different ways of using lighted pistons. So let's have a look at the boards and see what they can do, and also let's have a little bit of a think about how lighted pistons are used and how they work in a standard organ setup. Okay, so I've got a few lighted pistons on the bench here in front of me, and I've got our System 1 control board, which we've seen many times before. So what I'm going to do is just go through quickly what the connections are to these things, and then we'll have a quick look at the different boards, because as I just said, there are 6 different lighted piston interface boards within System 1. So as in previous demonstrations, I've got the System 1 control board on the bench in front of me. It's connected, its serial out is connected to the computer, and that's what's providing the power for it, and its MIDI out is connected through our usual Turtle Beach MIDI to USB interface, which is also connected to the computer. I have this little short Cat5 type Ethernet cable, and we're going to take a look at these lighted piston interfaces now. So we've looked at the other sockets on this board so far. We've been working our way around here if you've been following along in the other videos. So we're along to this one now, which is marked as lighted pistons. So one end of this lead is going to plug into there, and the other end is going to plug into one of our lighted piston interfaces. But there are a number of different ones of those. So first thing we'll do is we'll just have a very quick look at the different ones. We can move this back out of the way for the moment, because we don't really need to see it anyway. We've seen it many times before. And we'll just go through these boards. As I said, there are 6 different boards. So we've got this one. This is the first one to look at. And this does 32 lighted pistons, and it's for those that are arranged with a diode matrix. So it's an 8x4 matrix, the inputs for which are along the bottom here. So that's first board. We'll take a look at that in a minute. So move that out of the way. Then we have got the bigger one somewhere, and that'll be this one. So many boards I can't find the right one. So this is the same thing again, but this is for 64 lighted pistons, and they're arranged in 2 lots of 32. And there's various other sockets and things that we can look at on here as well, which we'll do later. And basically this is just 2 of the earlier boards that we just looked at, matrix boards, on one board. So there are 2 8x4 matrices on here. These are the rows, these are the columns, these are the rows, these are the columns. So it's matrix B and matrix A, but again we'll take a closer look at that in a minute. Let's move that one out of the way. Then the next one to look at is this one, which is for pistons that are not wired in a matrix fashion, but for those wired in a bus configuration. And this is obviously much simpler in terms of its connection. So we've got 32 inputs along the bottom for the pistons, and we've got 32 outputs along the edge for the LEDs. So that's that one. Then we have the bigger brother of it for 64 lighted pistons. So again, we've got 64 inputs along the bottom, because this is for bus configuration pistons, and we've got 64 outputs along the top. So we'll move that one out of the way. Then we have got this one, wherever it's gone, the smaller one of the 2. So this is pretty much exactly the same, and if I put them both there together, okay, so this is the 32 input bus input board that we looked at just now, and this one is exactly the same. The difference being though that this one supports much higher voltages. So on this one, the standard one, you can only use inputs of up to 5 volts. Anything more than that, you'll destroy the board and all sorts of other things, because obviously it's 5 volt logic levels for computers. But this one supports up to well, up to easily will support up to 100 volts on its inputs, not on anything else of course, but on these inputs here. And that's useful if you are going to connect this to, say, a pipe organ or some other kind of console that's already in use, and you're just tapping off of the connections on there, and you want to be able to still use that console in its original role. So if it's got, they're normally kind of well, 15 to 30 volts they tend to have on the pistons of those things, so you can connect those directly to this and there won't be a problem with it. So this is, as I say, exactly the same as this one, 32 bus inputs and 32 outputs. This is 32 bus inputs that can take higher voltages, so that's that one. And then coming back to our 64 input one, we have a high voltage version of that as well. So again, they won't all fit on the bench at the same time, but this is the one that we just looked at. So we've got our 64 inputs along the bottom, but these are only up to 5 volts, and we've got our 64 LED outputs along the top, and then this is the high voltage version of it. It's exactly the same in how you use it. We've got 64 inputs along the bottom and 64 outputs along the top for the LEDs, but again, this can take up to 100 volts, and it takes more than that actually, if it's pulsed. If you were to sit there with your finger on a piston all day long, things might start to get vaguely warm on here, but other than that, this is absolutely fine at those sort of voltages. So those are the 6 different boards that we've got, and we've got a few lighted pistons here. There are various types. These are just some that I bought off the internet. I've used these before. They're not massively expensive. They come from Switch Electronics. If you want to engrave the fronts, they're not really to be engraved, but what you can do is you just pop this little plastic cover off, which I'm not very good at doing, so that probably, oh no, there we go. So that comes out as a whole thing, and then you can just take the little plastic cover off of it if you've got strong enough fingernails, and then it's kind of slowly yielding. If it's going to let me do it. I think we're halfway there. No, it popped on again. Oh dear, come on. Well, I'll attack it with some tools later, and I'll show you, and I've broken my nail. But never mind. Underneath here, between the top of this white plastic and the actual clear cover, is a small paper disc, and you can obviously, if you've got the right tools or whatever it takes to get this thing off, it just clips on. I'm not certain how you're supposed to do it, but carefully I think would be the advice. Don't use a sort of small screwdriver or a knife or something, because you can guarantee that it will slip off and you'll hurt yourself, and that's never a good thing. But anyway, bottom line is it doesn't need to be engraved. It's got this paper disc inside, so what you can do is just print out on a sheet of ordinary paper all of the numbers and legends, whatever you want on here, and then just cut them out, the right size obviously. Take these plastic things off, pop them in, and then once you've done that, these just pop back into the piston whichever way around they go, and you're back where you started. So we've got these. We'll take a look at the connections to them that are on the back here. Also, I've got a couple of Kimber Allen ones which I'll show you as well. I couldn't find them in the latest catalogue actually, but I think they still make them, so we can look at those later. And then also what I'm going to do is we'll take a bit of a deep dive into how you can use this thing with Hauptwerk, because the job of a piston controller, a lighted piston controller, is very different to that of, say, a lighted stop controller, and we'll see why that is when we look at Hauptwerk with it in a little while. So what I'm going to do is I shall grab the small matrix interface first of all, and I'm going to plug that in. I'm going to get the computer going so that we can monitor what it's doing, and also I'll connect an LED to it, and we'll use our little test lead to simulate the switch on the piston, and we'll see exactly how that works, and we'll go through the various bits and pieces. and then we'll move on to the next board and so on. The high voltage boards, I'm not going to really spend too much time with those other than to say they exist, and I've explained why they exist. Their functionality is identical to their ordinary 5-volt ones, so we don't really need to look at those in any detail. So all I'm going to look at is this matrix configuration one and the smaller of the two bus configuration ones. We'll see how they work and what they do, and then we'll go into the Hauptwerk side of it and take a look at that as well. Okay, so I have got our System 1 Matrix 32 piston interface connected, so that's plugged into our main System 1 control board here. I've restarted the System 1 control board because whenever you plug anything in or change anything, then you have to restart the control board because it does a scan at startup, so it knows where everything is and what it's doing. Also, the jumpers at the back here, I've put this, there are two for our lighted pistons, LP polarity and LP mode, so they are both in the rearward position. The LP mode one we'll see later. If you put it in the frontward position, that's for bus type lighted pistons, but the rear position is for matrix type, and the polarity is just whichever way round the diodes happen to be connected in your matrix. So if you connect everything up and it doesn't work at all, then there's a good possibility that you just need to move that polarity jumper into the other position. So we'll move that board back out the way and we'll take a look here. Now I've connected our piston just temporarily via some little crocodile clip leads to output number 1 of our LED outputs, and the ground lead from the piston LED is just connected to ground, and I've just used these to save having to solder things and generally mess around like that. So I have got our little test lead here, which we've used before, and on the computer, so just get that running. Okay, so if we take a look at the computer now, on the right hand side we've got our serial COM session, and that's connected back to this USB connection here, which is also powering the whole thing at the moment. But that is for our serial communications, and then we've got our MIDI connected over here, I think, as I said earlier, with our little Turtle Beach MIDI adapter thing. And if we come back to the computer, on the left hand side, this is the output that we've received, or the input to the computer, the output from our System 1 control board when we started it up. So we've got 2 note events here, and as it says here, it sent note on there and it sent a note off there, and those are part of the power management system, which we'll look at in another video. So that's how everything's set up. We're using channel 10. All lighted piston activity takes place on channel 10 within System 1, and I've scrolled right down to the bottom left of the keyboard. So this is note 1, 2, 3, 4 and so on. Now this is where we get confused again, because it's that thing of the computer shows it as note 0 and everybody else sees it as note 1. But either way, that's where we're starting from. And what should happen is, if I get our little test lead here and I connect this between column 1 and row 1, then we should see on the computer, both in the MIDI monitor and on the serial session, we should see that sends the correct MIDI there. So I touched that and released it, and when I touched it, it said note on 0 and channel 9, so that's this thing of add 1 to everything that this tells you. And it's the same over here, so there's our note on 0 channel 9, and there's our note off 0 channel 9. And obviously this works as the same as any other matrix. So if we go to the end, we got note 7, we move up to our next column, start at the beginning, that's note 8, to the end of that is note 15, and so on, right up to the top where we get 31, which is really 32 because we have to add 1. So that's the matrix side of it, that's kind of our input bit. But You may have noticed whilst I was doing that nothing happened with our piston. It didn't light up at any point. So if I just do that again, if I connect the row 1 to column 1, so that's now sent a note on and a note off when I release it for the first piston, but this is not lighting up, and we'll go into why that is shortly, but that's just how this works. If I go back to the computer, if I press the note 1 key on the computer, you can see now that this lights up. If I turn it on and off a couple of times, if I can find the key again. So that's being controlled quite happily from the computer, but it doesn't switch on and off when we give it the input to the lighted piston interface. And that's really important, because we'll look at, when we look at how this works with Hauptwerk later on, we'll be able to see why we need it to work that way. But anyway, that's how that works. So what I'm going to do now is just going to zoom in a little bit closer onto this board, and we'll take a quick look at these sockets and see what they're for. Okay, so here we are zoomed in, and you can see the legend on the board here for this bottom right 16-way socket. It says incandescent lamp driver board, outputs 1 to 16, and then the next one up is exactly the same thing, incandescent lamp driver board, outputs 17 to 32. The incandescent lamp driver works with the lighted pistons, the lighted stops and everything else, and we'll look at that in another video. But basically the idea is that our LED outputs are exactly what they say. They will drive LEDs, they will not drive incandescent light bulbs, even if they're those super duper tiny weeny little things that you find in lighted stops. There's not enough power from this to drive those successfully. So you need to use, if you want to use those little things, you need to use a driver board, and that just plugs into here. So that makes that easy. And then on the left, over by our matrix input here, we've got this one which says TUTI strip compatible input. And what that means is that this socket is wired in exactly the same way as the sockets on the TUTI encoder. So anything that you can use with a TUTI encoder, you can use with this. You wouldn't really want to plug a keyboard into this or a breakout board, because all that's going to do is kind of expose these solder pads on a different board, so that would be pointless. But what it is useful for is using the TUTI connection strips, because if you don't have a matrix already, if your stops or pistons rather are not wired in a matrix already, and you want to wire them up that way, you've got to add diodes to each one and generally mess around and do that. Whereas if you use a TUTI connection strip, all of those diodes are on the strip and you can just plug that in. So I'm just going to grab one of those now, and I'll show you how that works. Okay, so here's our TUTI connection strip, and you can see it's got the matching socket to that, so you just use a straight through 1-to-1 16-way ribbon cable, IDC connections between those two things, and then you can connect your pistons to these, and it really is like you've got the two connections on the back of the piston. One connects to one side and one connects to the other side. It doesn't matter which way round you connect them, as long as you do connect them. All the diodes for the matrix are on the board. So these are, if you haven't seen these before, they're part of the TUTI range, if you like, and they're used for keyboards usually. So they actually have 64 inputs all the way along. Now this is an 8x4 matrix, so if you did use one of these, then only the first 4 columns would work. So you'd be limited to the first 32 inputs, but that hopefully is obvious because it's a 32 piston controller, so obviously you wouldn't use any more. So that's the idea of that socket there. And then you've got these two sockets, obviously to system board. They're the standard RJ45 sockets, hopefully you can see there, that we've used on all the other boards. And as with all of the other System 1 stuff, you can daisy chain these together. So you could get wherever it's gone, the 64, okay, you could get this 64 piston matrix interface, and you could connect from there to here. So now you would have 64 plus 32, and they would be numbered as 1 to 32 on this first board, and then they would carry on 33 to 96, I think it is, isn't it? Whatever it works out to, on the second board. And you can have up to 128 of the things in total, so you could then, if you wanted to, daisy chain out of here to a third board. So that's what those sockets are for there. So I think that pretty much covers the first of many of these boards. So this is the matrix piston controller for 32 pistons. We'll take a very quick look now at the 64 version of this, which, as I said, is virtually exactly the same. The only difference is it's two matrices on one board. So let me just plug that in quickly. We'll have a quick look at that, and then we'll move on to the bus connections. Okay, so I've got the 64 piston or matrix piston interface connected now. That's plugged in, as we can see, to the main controller. I've got our little piston LED connected up to number 1, as we did before on the other board, and I've got my little test lead here. So this is LED outputs A, and that goes from 1 through to 32. And this is our matrix A inputs here. So we've got our 8 rows and our 4 columns. And at the bottom we've got our matrix B with 8 rows and 4 columns, and then we've got our LED outputs B that run from 1 through to 32 again. And as per the smaller board, we have got our 2 TUTI compatible interfaces here, and we've got our 4, because there are now twice as many pistons, so we've got our 4 outputs for the incandescent lamp driver board. So that's 2 for these 32 LEDs and 2 for these 32 LEDs. So if we take a look at the computer, we've powered this up again and got exactly what we had before from our starting point. So what I'm going to do is go to matrix A, and I connect column 1 to row 1, and then release it, and as you see on the computer there, we get a note 0 on and off as I connect it and release it. And as you may have seen from the LED in the piston, absolutely nothing happens. So exactly the same behavior as its smaller brother. And if we then do column 4 to row 8, so now you can see that we get note on 31, note off 31, and then matrix B just carries on from there. So if we go column 1 to row 1 on matrix B, we get a note 32 on and off right up to the last 2. Column 4 with row 8 gives us a 63 on and off. And then the control of the LED from the computer, exactly the same as before. So if I send a note 0, as you can see, the LED in the piston lights up, and when I release it, it goes off again. So exactly the same behavior as the smaller board. So I think that covers the matrix interfaces, of which obviously there are 2, as you've just seen. So what I'm going to do now is I'm going to take the small or the smallest of the bus controllers, which is this one. This is 32 LEDs, lighted pistons. So I'm going to plug this in. I'm going to change the link on, if I can do this without everything falling off onto the board where it's not supposed to. I'm going to change the link here on the main board, this yellow one. I'm going to change this into the other position, because this needs to know that we're using bus type interface rather than the matrix type. And then we'll have a look. I'll connect this up the same way and we'll see how that works. Okay, so I've got the bus lighted piston controller 32 connected now. This is in the same lighted pistons socket as we had the matrix ones earlier. I've changed the link on the board, which you can't see, it's just out of shot there, but that's now in, well, I'll move it forward a bit, hopefully we can get that in without too much things getting in the way. There we are. Whether you can see that, hopefully you can, but that's now in the forward position, the yellow one, LP mode, so that's the foremost position is for the bus type interfaces. So as before, we've got our little lighted piston here, that's connected to output number 1, and the other side is connected to ground. And then we've got our piston inputs along the bottom here, and obviously our LEDs up the side. So the operation of this one is super simple. If you apply 5 volts to any of these inputs, then it will send a MIDI note on, and when you release the 5 volts it will send a MIDI note off. And as per the other interfaces, as per the matrix ones, if I send a MIDI note on for channel for note 1 or note 0, as it's going to appear confusingly on the computer, then that will light our lighted piston. So really pretty much as before. So to simulate this, we've got a plus 5 volts and ground pad here at the side, so I'm going to pick up 5 volts from there with my little test lead, and then I'm just going to touch that to piston input number 1, and as you can see from the computer, that sent the note on, and the LED in the lighted piston has not lit, and when I release it, it sends a note off. And then conversely, if I go to the computer, when I press the button there to send a note on, the LED lights up, and when I release it, it goes out. So that's pretty much all you need to know about this. It's got the same sockets here that we had on the Matrix one for the incandescent lamp drivers. Obviously it doesn't have a TUTI compatible input because it's a bus arrangement and not a matrix, but it's as simple as you can just apply power to these. And if we look at our pistons, I'll just grab a couple of them here. Normally when they're in the piston rail, they're all going to be the same way around. If you have them kind of on their side like that, it's really easy because you can connect all of the negative sides of the LEDs. You can just string a wire all the way along your piston rail. Obviously it needs to be insulated so it doesn't touch all the others, and that goes to ground, and then all the plus sides for the LEDs will go to all of your LED outputs on the side here, and that's as simple as it comes. And then the same for the switch. One side of the switch, and it doesn't matter which side, but probably the bottom side, because these are kind of easier to get in line and to whiz a wire through. You can connect one side of all of those together and connect that to 5 volts, and then you just run one wire from each of the other switch contacts along to the piston inputs, and that's it, job done. So really simple. 32 pistons, one board, and that's what that one does. As you will probably be expecting, there is a 64 piston version, and I'll show you that briefly, and then we'll move on to the next bit. Okay, so this is the 64 lighted piston controller, bus configuration lighted piston controller, and it's just twice as long as the 32. It's got all 64 inputs along the bottom, and it's got all 64 LED outputs along the top. We have our lighted piston here, if I can get him back into shot. So as before, this one doesn't have a plus 5 volts pad on it, so yes it does over here, so we'll grab some 5 volts from there. If I touch that to the first input, you can see on the computer it's come note on 0, channel 9. The LED in the piston has not lit up, and I release it and note off, channel 9, and that goes obviously all the way up to the last one here, which is note on and off 63. And obviously if I send the data from the computer, so number 1, it turns it on, switch that off, it goes off again. So that's the two controllers that we've got. 64 obviously if you've got a lot of pistons, 32 if you haven't. You can daisy chain them as with everything else in system 1, and you can have up to 128 pistons in total. So the next board to have a look at is the high voltage board of this. Well, we'll look at the 32 high voltage one actually, and basically what that's about is that you can't apply on these boards, the standard boards, you can't apply more than 5 volts to any of these inputs, because if you do, you're going to cause lots of damage very quickly, like instantly, and that will be the end of that, and it's not covered under the warranty either. So we've got the high voltage versions, and you can put on up to about 100 volts or more on these. So we'll take a quick look at the 32 piston version, and then even quicker look at the 64 piston version because it's the same but bigger, and we'll go from there. Okay, so I've got the smaller board connected up here. So this is the lighted piston bus controller 32 HV. So HV is for high voltage, meaning that, as I just said, we can put up to 100 volts onto any of these contacts and it won't do any damage at all. And then we've got our piston LED outputs at the side. Obviously these are not high voltage, these just switch the 5 volts to light the pistons in our to light the LEDs in our pistons. So whilst these are marked as high voltage boards, the only place you can apply high voltage is to these inputs. Anywhere else there'll probably be smoke escaping and it won't work anymore. So just to prove where we are at, we're not using our little test lead anymore, so we'll put him to one side. Instead we have this one which is connected to my bench power supply, and if I connect it to the meter it gets a bit carried away. What's going on here? Come on. Right, that's a bit more sensible. Loose wires. So we've got about 35 volts on here, 34.8 volts. So this lead has got 35 volts on it, let's say, and I can safely apply that to these, and this will work then in exactly the same way as the standard one that we looked at just now. So if I connect this to input number 1, for example, and you look at the computer, you can see that it's sent a note on, or it sent a note off and on again because it slipped off and so on. But anyway, note on when I connect it, note off when I release it, so on off, and I'll switch that back on again. As you can see, the piston is not lit up, so same behaviour as before, and at the other end of the board we can go to 32 and that sends the note on and the note off. So I'll just pop that back in the meter for a second. So as you can see, well, you could if the leads behave themselves. We've got 32 volts there, so that's perfectly resilient to that. And then of course from the computer end, if I send the note on 0, then our piston lights up, and when I send the note off, obviously it goes out again. So that is the idea of the high voltage one. It's got the same 2 sockets here for the incandescent lamp drivers if we want to use those, and that's really about all we can say about this. It's identical to the 32 piston regular controller or interface. The only difference is this one can take much higher voltages, as often found in pipe organ consoles. So that's almost it. We're nearly at the end of all of these now. I'm just going to connect up the 64 piston high voltage controller or interface, and we'll take a very quick look at that, and then we'll take a look at how we can use all of this with Hauptwerk, because as we said, it's not obvious the way the LED is controlled by the computer and not by this. So let's just take a quick look then at the 64 high voltage interface. Okay, so here we have the 64 piston high voltage controller or interface. We've still got our 32 volts or 32.7, more or less 33 on this red lead. As you can see from the computer, we're back at our starting point. So if I take this lead and I connect that to input number 1, we get a note on channel 9 on the computer, a note off when I release it, and at the other end we get a 63 on and off when I release that. And then when I press the first key here, sends a note on 0 on channel 9, which illuminates the piston, and when I release it, that goes out. So all as expected. We now have 4 of these sockets for the incandescent lamp driver boards, because we've got twice as many LEDs. So one board does 32 LEDs, by the way, rather than 64. So that's it for those. So what I'm going to do now, I'm going to put the nice easy one back, which is the 32 ordinary, not high voltage one, and then we're going to take a look at Hauptwerk and the computer and see what we can do and how we can make all this work. Okay, so here we are. We've got the 32 input bus variety interface connected with our little piston and LED, as we've seen before. And then if we come across the computer, as we've also seen before, we've got our MIDI outputs on the left and our inputs and so on, and we've got our serial connection on the right, so we can see what's going on with the controller. So if I press that, we get a lit piston 0 on and off, and as you can see, if you look at the piston, that lights up, that goes out. So we've done all this before, we know how that works, and we can do the reverse. So from 5 volts onto there, we get a note on, note off. Happy days. So if we now try and open Hauptwerk, it won't work because we've already got Pocket MIDI connected to our MIDI interface, and Windows will only allow one device to connect to a MIDI port, or any port actually, at once. So I'm going to close this and I'm going to start Hauptwerk. This is the old version 4, the free one, which I'm not sure if you can still get. However, we open that, we'll load up our St Anne's Moseley organ, and then we will look at what we need to do for our stops, or pistons rather, to actually work. So, right, there we are. Now, first thing we need to do, if we go to General Settings, MIDI Ports, we need to make certain that our Turtle Beach interface is selected for our console MIDI in, because if it isn't, then nothing's going to work. And we need to do the same for console, for the MIDI out, console MIDI out. That needs to be selected as well for the Turtle Beach interface. Now, that tells Hauptwerk to receive the MIDI from our System 1 and to send MIDI out to our System 1. So that's all good. We now have our usual view of the St Anne's Moseley organ, and it's got a few pistons along the front of the keyboards here, which obviously do their thing. However, what they don't do is light up. So obviously if I press piston 1, it operates those stops, but when I release it, nothing happens. I press piston 2, nothing happens, so on. So if these were lighted, one would expect that the first one would light up when you press it, and when you press the second one, the first one would extinguish and the second one would light up. And we've got 2 sets of pistons here, so this is why we need to have the controller set up so that it switches the lights on and off from the computer's commands and not from the controller's commands. Because if you think about this, if we just take these 10 pistons for a moment, just for argument's sake, so we've got 5 on the swell and 5 on the grate. So thinking about this, if these are just numbered 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on our controller, so these are the first 10 pistons. So looking at our controller for a minute, we've got 5 on the grate, and then we've got the next 5 on the swell, and then we've got 5 lights on the grate and 5 lights on the swell. When we press one of the pistons on the swell, we would want that to light up, obviously. So if we press number 1, then that's going to send a MIDI note on, or it isn't, but if they were lighted pistons, it would send a MIDI note on and it would light up the first piston. When we press the second piston, the first piston would need to go out and the second piston would need to light up. And when we press the 5th piston, the first 4 would be out, the 5th one would be on. Now bear in mind that as far as the controller is concerned, this first piston on the grate is number 6. So if the controller was handling this, it would need to know that, because otherwise when you press that one, it would turn that one off and light this one up, and that's not what you want. You would want that one to be lit and you would want this one to be lit. So that's why it has to work the way it does. So hopefully that makes sense. So then when I press the next piston, this piston number 5 would still be lit, but piston number 2 down here would be lit, number 1 would go out. Press that one, 5 up there would be lit, 4 down here would be lit. If I press that one, then 2 up here would be lit and 4 down there would be lit. So that would be almost impossible to achieve with the hardware in the actual piston controller, because it couldn't do it without knowing how these pistons are assigned on the actual organ console. And then of course, even if you did that, when you change or load a different organ, it's all going to be different again, because your next organ might have 8 pistons on the swell and it might have 8 pistons on the grate. So that has to be done from the computer. So that's fine. Moving forward then, how do we make these lighted pistons work with this thing? Because as I said, these don't light up anyway. What you can do, you can right click this and you can do auto detect, and then if we do our normal thing, so 5 volts to piston 1 and then release it, okay, so that's lit up, done now. We can select that, general cancel, and of course when we press our piston 1 like that, then it does its thing and these stops operate. But of course the piston doesn't light up, and the physical piston doesn't light up because this will not send MIDI out to make that piston light up. Now you can kind of say, oh yes it does, you can, because if you right click this and you do adjust things manually, you can go to the primary output and you can set your output to match the input settings, and you can click OK and it's happy with that. But all that happens is, if we come back to our bench view, when I operate our piston number 1, whoops, as you can see, the piston lights up. But as soon as I release it, it goes out. So that's no use whatsoever. So yes, whilst Hauptwerk does it, it's not really very useful. So let's just clear all those MIDI settings, general cancel. So to make this work with any Hauptwerk organ, what we have to do is use Hauptwerk Scoped Pistons, and that's what these are along the top up here. So the way we get to those, if we go to view, we want our mini floating control panels for this organ, and we want our master scoped combinations. I've just chosen bank A. You can have more than one, obviously. So that's where that comes from. And then our large floating control panels, we can go to our master scoped combinations all, and that gives us all of those. So we've got 60 actually scoped pistons that we can use. I'm not going to go through how you set all of these up in Hauptwerk, because that's not really for a discussion for this. This one's about how we make our lighted pistons work with these pistons. But there are some good videos on YouTube that show you how to do this, and how you can set these as generals, you can set them as divisionals, you can set them as anything you want, and this is the little board you use to do it. But we don't need that for the minute. All we need is to have these available at the top. So as with normal pistons, if I click on the first one, it lights up in inverted commas, as it were, because it goes a different colour on the screen, and you can see it brings these stops out. If I click on the next one, then normal behaviour, you would expect that one goes out, this one lights up or changes colour, and you get the registration for that one. The next one hasn't been programmed at all, so it doesn't bother lighting up. And if you go back to one of the ones that has been programmed, when you press general cancel, obviously that goes out. And also any of the ones that have been programmed, as soon as you move away, if you change that registration manually, then that piston goes out, because it will only come on when the registration that's actually set matches that was saved to that piston. So normal kind of piston behavior within an organ. So how do we make this work with our piston controller? Very, very simply. All we need to do is right click that and do auto detect, and then we come over to our piston controller and we're going to use number 1 again. So we do 5 volts to piston number 1, and then we release that. And then if we look at the computer, it's seen that. It says send matching MIDI output to control this MIDI draw, stop, knob, tap, switch, etc. And it shows us the MIDI output. So yep, we want all of that, so we click done. And we'll do the same for piston number 2. So auto detect, and this time we do our 5 volts onto number 2. That works, and we click done. So if we now click general cancel, and then we do our 5 volts to piston number 1, as you can see, that's operated the piston on the computer, but also our piston is lit up, which is what we want. And then if we select the second input instead, so we now do number 2, our little test piston has gone out, because obviously that's gone out on the screen here, and the second piston has lit up, and we can prove that by moving our little test lead across to the second one, and that's now lit up. And if we press general cancel, obviously that goes out, and it's that simple. That's all you need to do, basically. The hardest part is setting up these scoped pistons as you want them in Hauptwerk to be your generals or divisionals or whatever, and then setting all the registrations to them. But as far as using them with the actual piston controller, it's just a matter of simply right click it, auto detect, put the piston, or press the piston and release it, and make sure that, let's just do that so we can see it on the screen again. Okay, so we've done that. Make sure that this is ticked, send matching MIDI output to control it, because without that obviously it won't light up, and you click done, and that's it. It's that simple. And you've got 60 of these scope pistons available within Hauptwerk, so that should be, well, hopefully anyway, that's enough to control what you want. I think maybe some of the bigger organs may have lighted pistons as part of the console representation here, that you can right click and do it from there anyway, but that's basically how all that works. So that was a bit of a long drawn out explanation for everything, but hopefully now you can see what we've got, why we need so many different boards, and also once we've worked out which sort we're going to use and got them all connected up, we can see how we use them in Hauptwerk. Grand Org is very similar. I don't know if it has scope pistons, but the pistons, the general pistons on the organ, the standard default organ that comes with Grand Org, they work fine and they light up anyway. So again, all you need to do is right click them, do listen for event, you press and release your piston, and that's it. It just works thereafter. So it's really that simple. So there we are. That's lighted pistons. The next video is going to be on the System 1 auxiliary board and the 7-segment displays, and we'll see what we can do with those and why we have them. And I hope this was useful. I'll see you in the next video. Okay, so I finally got this thing apart. These are really awkward to prise these little plastic caps off the front there. I ended up using a very small screwdriver with it that way up against the bench, and you have to work your way around very, very carefully and gently to make sure that you don't break the thing. But eventually this does come off, leaving you with this part and this little plastic disc, which I can't pick up, so one moment. Right, so, and this little plastic disc. I was wrong about the paper. I thought there was a piece of paper in here, but this appears to be just a piece of translucent plastic. So I still see no reason why it actually goes that way up, because it sits in the top of this, like so. So you could engrave the front of this if you had a laser engraver or something like that. Or you could use sticky letters or whatever, but personally the light's quite bright that comes from these things, so I would still say the best way of doing this is to print whatever you want out on paper, and then you can just kind of draw around that if you like, and then just cut them out to fit. And obviously you would put this thing in first, and then you'd put your paper in here in the plastic cover bit, and then you'd put the two together and you just press them back on, and I hope they go together easier than they came apart, because yeah, there we go. So that took a fair bit of force, but it's back in one piece now, and then this just goes back into the actual piston, and you have to give it a good old push. It clicks in, and there we are. So that's not going to fall out, and that's how those work.